All right, what we're going to do is we're going to do some proving today on how to find, all right, the derivative of arctangent, arc cosine, and yes, we won't forget little arc secant. Now, the other ones, as you know, are cotangent, arc sine, and arc uh, cosecant can also be found, but we're going to find these right here. So, um, starting off, we're going to start with arctangent. Now, in order to find this, these are inverse trig functions. So in order to find inverses, I'm going to start with the tangent function. Actually, switch x and y's. We're going to start with this. Okay. So because these are inverses, I'm going to start with an inverse function of one that we know. Y equals tangent of x. So the inverse of y equals tangent of x equals tangent of y. Now, what do we have to do now? Well, we're going to take the derivative of this with respect to x. So now this is what we call an implicit form. Okay, and what we have up here for our inverse is actually an explicit form. And explicit form because we have y equals in terms of x. Implicit, we have our y and x, and the tangent of y makes it a little bit more implicit. So we're going to take the derivative of this. We're going to have derivative of x with respect to x is 1. And that's going to be the derivative of tangent using a little chain rule action. We got secant squared of y times the derivative of the inside, which is going to be dy dx or y prime. All right, y prime. I'm just going to put y prime there. Okay. Now from here, we're going to just solve for y prime. So what does y prime equal? All right. I took the advantage of using cumulative property. We have 1 over secant squared of y. So some of you would say, well, okay, so the derivative of arctangent is secant squared of y? Yes and no. This is the implicit form, all right, of actually this function. Well, how do we create this in this function? Well, we have to put this in terms of x. So we're going to change this into an explicit form, and this is where the math magic comes in. All right, this is it says explicit. I apologize for my poor writing. So right here, we have to think, okay, how can we change secant squared of y? Well, we're going to use a little bit of identities. And if you recall your identities, we know that 1 plus tangent, in this case, tangent squared of y, equals secant squared of y. We know that is one coming from our basic trig identities. Other basic trig identities we know is sine squared of y plus cosine squared of y equals 1. We also know that 1 plus cotangent, all right, squared of y equals cosecant squared of y, and so on and so forth. Okay, so from this, I'm going to replace this over here. Okay, I'm going to use a little substitution. So we have actually y prime is actually going to equal 1 over 1 plus tangent squared of y. Now, this is where the mathematics comes from. You might be thinking to yourself, hey, Mr. Gottschalk, that didn't really give us. We just changed one implicit equation into another implicit equation. How do we get to the explicit formula so we actually know what is the derivative of arctangent of x in explicit form? Well, my friends, what does tangent of y equal? Well, in this problem, we said that tangent of y equals x. Oh, so actually this equals y prime actually equals 1 over 1 plus x squared. And that, my friends, bada bing, bada boom, is the derivative of arctangent. All right, this is actually the derivative of arctangent of x. Boom, nailed it. And if you want to know the derivative of the cotangent of x, well, we go through the same process. The thing is that when we take this in cotangent, we're going to have negative cosecant squared, which then makes it into the opposites. So the derivative of arc cotangent of x is actually equals the negative 1 over 1 plus x squared. All right, and so that is what we know. All right, cool. Hope you thought it was interesting. If you thought that was cool, let's try cosine. Well, in order to figure out the arc cosine of x, we're going to switch X and Y's. All right, switch X and Y's because we're going to put this in implicit form because we know that this is actually the inverse. All right, the inverse, as we said before, of Y equals cosine of X. And so we're going to write this in inverse of that, and we have this right here. Once again, go through the same steps. We're going to take the derivative of this with respect to X, and we get 1 equals, all right, negative sine of Y times Y prime. So what do we have here? Well, it's going to be equal 1 over negative sine, all right, sine of Y. That equals Y prime. Now, once again, this is in implicit form. We don't want this implicit form. We want it in explicit form. Explicit means that we have in function notation, all right? And so what do we need to do? Well, we need to do very something similar that we have over here. Well, we know that cosine of Y, so can we change this sine of Y into a cosine? Well, yes, we can. Yes, we can. And so looking at this trig identity, we actually know, I'll change the color, we know that sine of Y, solving this, actually equals the square root, I'm just going to bring the positive portion, all right, of 1 minus cosine squared of Y in this case. Oh, using this equation right there, we know we're going to have negative 1 over the square root of 1 minus cosine squared of Y. All right, that actually equals Y prime. That equals Y prime. Well, that, using a little substitution, we know that cosine of Y is equal to X, so this is actually going to equal negative 1 over the square root of 1 minus X squared. Boom! Nailed it. That is what we know. That is actually the derivative of our cosine in explicit form. This right here is the derivative of arc cosine of X. If you wanted to figure out what's the derivative of its partner in crime, arc sine of X, arc sine of X, well, guess what? Very similar to when we figured out what the derivative of tangent and cotangent. This one is going to equal, all right, just simply the positive 1 over the square root of 1 minus X squared. And the reason why is because when you take the sine, the derivative of sine is cosine, just positive. So we don't have this negative. We go through the same process, except solve for cosine, and we get this other answer. So, once again, derivative of our cosine is negative 1 over the square root of 1 minus X squared. Using this trig function, that's why we have it. All right, this is a little long video, so if you wanted to fast forward, I totally understand. But let's get the test de distance, le fin. All right, what do we got when we have secant of X? Secant of X. Well, same thing. This is implicit form, and so what we want to do right here is we're going to use its good old inverse. So if we had Y equals, all right, secant of X, we know that we need to find this is the inverse of that. And so therefore, we're going to write it like so, in implicit form. See how implicit differentiation is so important? All right, how it all comes together. I love math. All right, so we're using this implicit formula. We're going to take the derivative of this with respect to X. All right, once again, just like all the other ones, we have 1 equals, that's going to turn to be secant of Y times tangent of Y. All right. So now from here, what are we going to do? Well, going from this, we know that we have, oops, I forgot to multiply by Y prime. Don't forget your Y prime. All right, so the derivative of secant is secant tangent times the derivative of the inside, which is Y prime, using a little chain rule action. All right, that's what we did with all the other ones, implicit differentiation. And so now we know that Y prime actually equals 1 over secant of Y times tangent of Y. All right, that's cool. That's neat. That's awesome. Now, the question is, all right, when we have secant of Y tangent of Y, how is this related? What is the derivative of arc secant? What's the derivative of arc secant? This is an implicit form. Now, if you recall, what we did was use a little substitution. Well, notice that secant of Y equals X. Secant of Y equals X. So, we can use a little substitution. We know that X times tangent of Y. Cool. We also know right here is that we have 1 plus tangent squared of y equals secant squared of y. Solving for tangent, we have secant squared of y minus 1. Take the square root, only add the positive. And then we have tangent of y. Oh! So tangent of y is going to equal, all right, the square root of secant squared of y minus 1. Alrighty dighty, oakley dokley. From here, what do we know that secant of y equals? Oh, that equals x. So we have 1 over x times the square root of x squared minus 1. Boom. Nailed it. All right, and that's what we have right here. Okay. Our x values, when we have this is going to actually equal then, my friends, all right, the derivative of, which is y prime, all right, which is actually equal to the derivative of the arc secant of x, okay, arc secant of x. And so when you have this, we know, all right, if we did the opposite, and I want to find what's the derivative of arc cosecant of x, it'll be the same process, except when we take the derivative of cosecant, we get a negative. And that's why we have a negative 1. And then we'll still have this x times the square root of x squared minus 1. And that is all of our inverse trig functions, where they come from, why we use them. Many books, all right, have this as the absolute value because we want to make sure that this value is positive. However, in our proof right here, if you have x, that would be fine as well. All right, so yes, we have just nailed down all of the inverse trig functions and why they are what they are, all right, using implicit differentiation. I hope this helps you out. I hope this makes a lot of sense. And yeah, and I hopefully you can do some chain rule and get these right on your future test. All right, good luck and God bless in the rest of your problems, my friends.